Greetings, Leon Panetta and your fellow colleagues from the U.S. Secretary of Defense. This is an informative DVD on Operation Catapult conducted by IMC by your request. This DVD includes an explanation of our design, the footage of our test trials, and our final trial. It has been an honor working with you. Please enjoy this informational DVD.
Before we started building, we drew a design of what we wanted our catapult to look like. In consideration of your request for a lightweight, easily transported machine, we designed a model that will fit your needs. After the process of creating the catapult design, we then calculated the measurements for the wood we would need using addition and subtraction. Before we go any further, it must be made clear that if anyone tries to repeat the steps we took to build a catapult or of his or her own, they must take the proper safety precautions, such as wearing safety goggles, gloves, and closed-toed shoes. I also advise that someone with experience in power tools be present during the building process to prevent any unfortunate situations.
After we calculated the necessary lengths for our catapult, we went to the store to gather supplies. All of the wood that we got was 2 by 3 inches. We gathered 2 pieces that were 7.5 inches long, 3 14-inch pieces, 2 pieces that were 24 inches long, 1 28-inch piece, and another that was 10.5 inches long. Other than the wood to build the catapult, we used an adjustable bungee cord, 2 large and strong eye hooks, a bunch of long screws, a red solo cup, and a long dowel that was 1 inch thick and 24 inches long. All of the supplies that were needed are shown here.
Once we had the pieces of wood cut to their appropriate lengths, we had to modify a few of them. This was the hardest part of the building process, but once it was done, everything goes pretty quickly from there. The first thing we did is cut out sections from 2 of the pieces of wood so that we were able to form them into a joint. We used a handsaw, a chisel, and our safety gear. Making the joint is an important step because it is what makes the catapult strong.
To cut the hole to form the strong joint, take one of your 24-inch long pieces and cut a 3.5 inch from the end. This is your pivot hole. Drill a hole here that your pipe will slide through. Do the same for both of your 24-inch long pieces. Then make a mark at 5.5 inches and 8.5 inches from the end. Draw the line for this as shown in the picture.
Now use a chisel and hammer to chisel out the excess wood. Next, repeat the process we just did on your other 24-inch piece of wood. After that, we did the exact same thing to the 14-inch pieces, but we only cut off the very end of each piece. Mark a line 2.5 inches from the end and then cut down with the saw halfway through the wood. Then chisel away the excesses. Now this piece will fit nicely into the piece you made in the step before. Now that you have cut the notch into the 24-inch piece and cut the notch into the 14-inch piece, they should fit together nicely. You still have one remaining 14-inch piece, and that is okay. Do not cut a notch in that third one. We will custom cut that one later.
Now take your 2 24-inch pieces and your 2 7.5-inch pieces and screw them together as shown in the picture. Make sure that the notches you cut into the wood are on the outside of the assembly, not on the inside. Screw one of your big eye hooks into the end as shown. Make sure it's at the end nearest the slot in the hole you cut in the long pieces. Drill a pilot hole if you are having difficulty getting the screw in. A pilot hole is a very thin hole drilled as a starter. It makes it easier for the screw to go in.
Now screw the 2 upright pieces into place. Now screw your 10.5-inch piece across the top of the 2 upright pieces. Make sure it is on the side shown. It should not be on the side nearest the metal hook.
Now take the final 14-inch piece of wood and custom cut the end so that it is at an angle. Then screw it directly in place like shown. This cut can be a little tricky, but just carefully measure it by holding it against the catapult and drawing lines on it. This piece shown here has already been cut at both ends with a right angle and just needs to be screwed into place. This piece is rather important because it adds a lot of support to the catapult.
Take your 28-inch long piece and drill a hole in one end so your pipe slides easily through it. It should be a loose fit so the swing arm will pivot freely. Next, take your red solo cup. Using scissors, cut the top half of the cup off so the cup is twice as small. The cup will hold your projectile. In the picture shown, a red solo cup is not used, but we found that the cup works better. Once the cup has been cut, you can screw the cup onto the end of the 28-inch long piece on the opposite end of the side you cut the hole for your pipe. Next, put your other eye hook into the center of the swing arm a few inches below your cup. Make sure it is nice and tight.
Now to finish it up, slide the pipe through one end of the catapult, through the swing arm, then through the other end of the catapult. Put a couple of screws in it to hold it firmly in place. Then attach the bungee cord and you're ready to go. Once we had our catapult built, we conducted several test trials to test it out. Here is footage from those first trials.
During our final test trials, we launched the catapult 5 times, each time collecting data on how long the projectile stayed in the air and how far the projectile traveled. Then, using quadratics and formulas associated with projectile motion, we calculated the initial horizontal and vertical velocity, how high the ball went, and how far away, vertically and horizontally, the catapult needed to be from the target in order to have the projectile land accurately in or on the target. After we did our calculations, which can all be found in our written report, we then conducted our final tests where we set the catapult the specific distance away from the target that we calculated was needed, and then launched the catapult several more times. To our enjoyment, our catapult showed that it had a very accurate launch. Here is footage from our final test.
Our catapult was not able to launch 10 yards, as you just saw. When you imitate the steps we took in order to make a catapult of your own, there are several things that you can do differently in order to make your catapult be able to launch 10 yards. The bungee cord is the most important aspect of the catapult. Using different cords will change the strength, thus making the ball go further. The length of the swing arm also has an effect on how powerful the catapult is. Generally, the longer the swing arm, the more power you'll get, so try using a piece of wood that is longer than 28 inches. When you do this, you'll probably have to tinker with the location of the crossbar to get this just right. Another thing you could do to make your catapult stronger is using a metal pipe instead of a wooden one to reduce friction during the launch. We hope that all of our work is satisfactory to you. It has been a pleasure working with you. Good luck in recreating a catapult of your own.